In this video, we're going to talk about horizontal expansions. So I have a video on vertical expansion and a video on vertical compression, so if you haven't seen those, you might want to check those out. And this video, horizontal expansion this time. So what we have here, we've got, some original graph, y equals f of x. We're expanding that graph to y equals f of a times x, where a is a number that's less than 1. So if a is something like a third, or a half, or 0.5, a decimal, you've got a horizontal expansion. So it might seem sort of strange to you that we're multiplying by a number less than 1, and that equals an expansion. That seems a little odd. So I'm going to show you through graphing how that makes sense, but a lot of times when we're graphing stuff, we've got, y equals x minus 2. That would be a translation, and we always think, do the opposite of that. What's the opposite of going 2 units to the negative side? Over here we'll be going 2 units to the positive side. So a lot of times when we're graphing things like that, if you think, do the opposite of what, kind of seems like it would make sense, that's usually the correct way to do these questions. So we're going to start with y equals x squared, just our standard parabola. So in this case, x squared is going to be our f of x. We had y equals f of x, we've got y equals x squared, so it makes sense. X squared is our f of x. So let's put together a quick little graph. So our regular parabola has a point at x is negative 1, y is 1, it's got a point at 0, 0, and it's got a point of x is positive 1, y is positive 1. Connect the dots. You got something that looks like that. So I'm going to switch to my green pen now, and we're going to see how does y equals f of x compare to y equals f of, I don't know, what should we do? Maybe a half x? So this is an expansion. A is less than 1, right? It's a fraction that's smaller than 1. It's a half. So what that means is y equals a half of our f of x was x squared. So let's make a little xy chart. X is negative 1, 0, and 1. So if x was negative 1, we would have negative 1 squared is positive 1, times a half would be 1/2, or 0.5 would be the same thing as the decimal. If x was 0, 0 squared is 0, times a half is also 0. We've got a point at 0, 0. And if x was positive 1, 1 squared is 1, times a half. This one is also a half, or 0.5 y value as a decimal. So let's stick those points on our graph. We've got a point at, we used to have a point at negative 1, positive 1. Now we've got a point at negative 1, a half. We've got still a point at 0, 0, and now we've got a point at positive 1, a half. So I think what I'd like to do is add another negative point and another positive point, and we'll get a little bit more of a dramatic difference in our graphs. So let's let x equal negative 4 and positive 4. So if x was negative 4 squared is 16, times a half would be 8, and if that was positive 4, it's also 16 times a half would be 8. So we've got a point at negative 4, 8, so somewhere way up here. And then we've got a point at positive 4, 8, way up here somewhere, and connect the dots. Okay, so you can see that what we've got is a much more expanded graph than what we had originally. Notice that the point at 0, 0 does not change. And the idea of these graphs is, if we had, used graph paper, had a really nice scale, then where our y value was 1 on our original graph, our new graph should be a half, and it should line up on the same xy point. It would be a half because that's what we had over here. Where y is 2, if you go straight down, we should have been at our 2 point, and now where x is 2 used to be at y equals 2, now it's at y equals 1. The x points have half the y value that they used to. So in my next video I'll talk about horizontal compression, so stay tuned for that, and I'll see you guys then. Bye.